Good evening, friends. Thanks for coming by. I'm glad there's a few people here to watch live. As always, please add your comments. I'll do my best to take a look at them and address them if I can. Tonight's lesson is pretty challenging. Product to sum and sum to product identities. It may be one of the more challenging lectures in the course. So if you have any questions, again, please put them in the comments and I will do my best to address them. I apologize that we have to continue doing this. I sincerely hope that the teaching assistants strike is settled soon. But one advantage you have of these live lectures is you can watch them multiple times. So I did ask you, if possible, to take a look at the problems before the lecture. If you did that, great. If not, after you watch the lecture, I suggest that you try to complete those problems again and see if you're able to do so. All right, so it is 7:30. I think we can begin. I want to do a quick review of the main facts that we had on the previous lecture. So I'm going to start with this one. Cosine of A plus B is cos A cos B minus sine A sine B. You don't have to memorize these. I will provide them to you on the next exam, which is coming up in just a couple weeks, by the way. Notice the sign changes. It's plus here and it's minus there. The next one we have is cos of A minus B is cos A cos B plus sine A sine B. Again, notice the sign changes. Here it's minus, there it's plus. So when we're doing cos of sum and differences, we have a sign change. I hope that's fairly easy to remember. Next up, we have sine of A plus B, where we do not have a sign change. So sine of A plus B is sine A cos B plus cos A sine B. Notice the plus sign here and the plus sign there. That is going to stay the same. And then with sine of A minus B, again, the sign stays the same. Sine of A minus B is sine A cos B minus cos A sine B. Now, the first real use of these is to go with cos of 2 theta. Notice if A is theta and B is theta, cos theta minus sine theta. So theta plus theta is 2 theta. Cos squared theta minus sine theta, sine squared theta. This is what I would like you to memorize for calculus for sure. And similarly for sine of theta plus theta, sine of 2 theta, if A and B are both theta, sine theta plus cos theta sine theta, they're the same. Sine of theta plus theta, sine of 2 theta is 2 sine theta cos theta. So those are the important identities we developed in the last lecture right before spring break. If you did not watch that, please go back and take a look at that one again. I think that's an important one to look at, and obviously spring break kind of breaks up our continuity. So we're going to add some new identities to our list. These are going to be challenging. We're not going to prove all of them, but I will certainly prove one of them. So let's start with our product to sum identities. Why do we call it that? Product to sum identities. Well, this is a product, sine A times sine B. I want to turn sine A times sine B into a sum of two things. This minus this times a half. So it's a difference, but of course, we can think of a difference as a sum by adding a negative. So that's our first rule that we're going to deal with. And I would like to prove that if I can. So before I give you the rest of the product of sum identities, let's try to prove that. Normally speaking, we start on the left-hand side, but I think it's obvious here that the right-hand side is the more complicated side. So if I'm going to go ahead and prove this identity, I'm going to start with the right-hand side. So the right-hand side equals 1/2 cos of A minus B minus cos of A plus B. So we just saw the identities on the previous page that we're going to work with. So I hope that we can use them. So if we recall, cos of A minus B is cos A cos B plus sine A sine B. So let's go ahead and put it in parentheses here. Cos A cos B plus sine A sine B. So that's our first piece, minus cos of A plus B. What is cos of A plus B? Cos A cos B minus sine A sine B. So again, I'll put that in parentheses here for us to see. Cos A cos B minus sine A sine B. And we need to go ahead and simplify this and see if we indeed get our left-hand side. So what I'm going to do is eliminate the parentheses. So we have 1/2 cos A cos B plus sine A sine B. The parentheses aren't really doing anything for us there. And then let's distribute this minus sign. So it's going to be minus cos A cos B. And then we have minus a negative. Minus a negative is going to become plus sine A sine B. Sorry about that. Plus sine A sine B. And you'll notice that we have some cancellation here. Cos A cos B, boom. Minus cos A cos B goes away. So where are we at? We are at 1/2. Sine A sine B plus sine A sine B is 2 sine A sine B. So 1/2 of 2 times sine A sine B is going to equal sine A sine B, which if you look on the top of our page here, was our left-hand side. So we wanted to get all of this to equal sine A sine B. That equals the left-hand side, and we have successfully proven that identity. So all of the identities I'm going to share with you in tonight's lecture, product to sum and sum to product, can be proven using versions of cos A minus B, cos A plus B, sine A minus B, sine A plus B. So I'll encourage you to take a look at those and see if you can go ahead and prove these. But more importantly, you need to be able to use them, and that's what we're going to focus on today. So let us take a look. We have a few more product to sum identities for you to work with. So I've given you this first one that we've actually proven. Let's go ahead and take a look at some others. So we have cos A cos B is 1/2 cos A minus B plus cos A plus B. Sine A cos B is 1/2 sine A plus B plus sine A minus B. And again, I encourage you to try to prove those as you move along. All right, well, let's see if we can do a problem using these identities. So here's the first one that we'll try to do. So I've got sine 195 degrees times cosine of 75 degrees. So we have sine times cosine, so I hope it's obvious that we're using this identity right here. Sine something, cos something. So let me go ahead and rewrite that identity. So I have sine A cos B equals 1/2 sine A plus B plus sine of A minus B. So what is what in this problem? 195 degrees is going to stand in for A. 75 degrees is going to stand in for B. So wherever we see A and B, we're going to replace it with 175 and 75. So what will this be for me? What am I going to have? Well, I've got sine 195 cos 75. Sine 195 degrees cos 75 degrees is 1/2 the sine of A plus B, the sine of 195 plus 75, plus the sine of 195 minus 75. So you can see that this is going to be relatively easy for us to finish. What are we going to get then? 1/2. 195 plus 175 is 270. So we get sine 270 degrees plus 195 minus 75 is how much? That's going to be 120 degrees. Okay, so at this point we can go ahead and simplify. Let's remind ourselves where 270 degrees is. Always use the unit circle to kind of help us understand this. 270 degrees is down here. The x value is 0. The y value is -1. This, of course, again, is 270 degrees. So the sine of 270 degrees is the y value. Sine of 270 degrees is -1. So what I get is I get 1/2 sine of 270 degrees is -1 plus The sine of 120 degrees. Let's see what that is. 120 degrees is in the second quadrant with a reference angle of 60 degrees. So if we see that, that's our story. Reference angle is 60 degrees. So there's 120. We want to figure out what the sine of 120 degrees is. Well, sine of 120 degrees, we are in quadrant 2, so sine is positive. The reference angle is 6D. Reference angle is 60 degrees. So sine of 120 degrees is the positive of the sine of 60 degrees. Positive because it's in quadrant 2. Sine of 60 degrees because 60 degrees is the reference angle. And the sine of 60 degrees, of course, is root 3 over 2. So I get positive square root 3 over 2. So that answer is correct. Make it a little bit cleaner. Let's go ahead and distribute the 1/2. 1/2 times -1 is -1/2. Plus 1/2 times root 3 over 2 is root 3 over 4. So that's the process that we use to go ahead and use that product and turn that into a sum. In calculus, that's helpful for doing certain integrals that are challenging. So I want to make sure that you have those things down. All right. So we had 3 product to sum identities. We'll take a look at them again here in a couple seconds once I think you've had a chance to copy all of this down. And then we'll see where we are. So we had 3 product to sum identities, and we proved the first one. Again, here they are. And these are relatively easy to use as long as you define A and B properly. But when this gets difficult is when we jump to the sum to product identities. So here we go. We have 4 identities here that are sum to product. Sine of A plus sine of B is 2 times the sine of A plus B over 2 times the cosine of A minus B over 2. Similarly, sine of A minus sine B, 2 times sine A minus B over 2, cosine A plus B over 2. Cosine of A plus cosine of B, 2 cosine A plus B over 2, cosine A minus B over 2. And cosine A minus cosine B is -2 sine of A plus B over 2 sine of A minus B over 2. So in this situation, we are starting with a sum and we are getting a product. If you wanted to prove this, now that's going to be challenging. Rewrite that as sine of A over 2 plus B over 2, and then do your sine of something plus something identity. Cosine of A over 2 minus B over 2, then do your cosine of something minus something identity. Do all that together and you should get sine A plus sine B. That would take a long time to do here, so I'm going to encourage you to do that on your own. Now, in light of this, I want to go ahead and do another problem. We want to figure out what we're going to use here with our sum to product. So this time, let me go ahead and do sine 75 degrees plus sine of 15 degrees. So we're going to use our first identity again this time to go ahead and make that work. On the email to you, I sent you folks a list of these identities. So if you don't get these all copied down, you certainly can get them from that worksheet. So here we go. Sine of 75 degrees plus sine of 15 degrees. What's that going to equal? Well, let's go ahead and write down our identity underneath it again. Sine A plus sine B. So in our example, A is going to be 75 degrees. And B is going to be 15 degrees. Then we're going to go ahead and make our substitutions and see what we get. All right, well, I'm going to take a break here for a minute and let you guys try that. So go ahead and plug those numbers in and see you get an answer. And we'll see if 1 or 2 of you are brave enough to put your answer in the comments section. So again, I'll let you go ahead and do that. Hopefully our comment sections are working tonight. Question I have in the comments, these identities will be given on the exam. Yes, that's our plan. So I emailed a list of identities. Those should be included, or at least most of those should be included on your next exam. We'll clarify that as it gets a little bit closer in terms of what you'll have access to, what you won't have access to. But these nasty identities we're working with tonight, you will absolutely have access to those on the exam, for sure. I sincerely hope that this strike gets settled soon. I don't know whether to be hopeful or not to be hopeful on this, but I'm looking forward to returning to class. I'm not sure what Jenny Shrikant is doing, so if you're one of her students, you'll have to contact her to see if she is planning on meeting in the discussion section. All right, again, I'm waiting for someone to put an answer on the chat board. As soon as I get one or two, I'll give it a try to show it to you guys. See what you got. Again, hopefully spring break was good. My wife and I went to New Orleans, had a terrific time there. Very nice. All right, so thank you, Carthard. 2 sine 45 cos 30. So if we can simplify those, you can take a look at that strategy, see if that's right. But I think that is, so that's a pretty good start. Anybody simplify that for us and give us a final answer we can deal with to see if that is right. Wait maybe for one more comment before I jump in. Do you distribute the 2 to the degrees or to the points? I'm not sure I understand what that means. There's no distribution involved here because 2 is a number, sine 45 is a number, cos 30 is a number. So we don't have multiplication over addition. So I don't think distributing is what we want to do here. All right. Anybody else have an answer for me? I'm losing people. I see the numbers of watchers is going down. So I'll take that as a sign to get started. So in my discussion here, 75 is A and 15 is B. So I have 2 sine. A is 75 plus B is 15 over 2. Cosine 75 minus 15 over 2. What is that going to get me? That's going to get me 2 sine. 75 plus 85 is 90. 90 over 2 is 45 degrees. So that's what we saw earlier when the answer that's posted on comments. I appreciate that. 75 minus 15 is 60. 60 divided by 2 is 30. 2 sine 45 cos 30 degrees. And I hope we can always keep in mind our favorite table. 0, 30, 45, 60, 90. Normally we use radians. We don't need it here. Sine of 0 is 0. Sine of 30 is a half. Sine of 45 is 1 over root 2 or root 2 over 2. Sine of 60 is root 3 over 2. Sine of 90 is 1. And for cosine, you just read it backwards. 1, then root 3 over 2, then root 2 over 2, then 1/2, then 0. So to sine of 45 is root 2 over 2. Times the cosine of 30. Cosine of 30 is root 3 over 2. And yeah, there's no distribution involved here. What we need to do, though, is you recognize these are 3 fractions that are multiplying. So 2 over 1 times root 2 over 2 times root 3 over 2. The 2's will cancel. 2 goes away, 2 goes away. That, of course, becomes a 1. That becomes a 1. Upstairs, I have 1 times root 2 times root 3, which, of course, is root 6. Downstairs, I have 1 times 1 times 2, which is 2. So one answer for that is root 6 over 2. All right, let's take a look at one more of these. I want to go back to another product to sum question. So you've got your list of identities. See if you can do the following for me. I want sine of 285 degrees times the sine of 75 degrees. So we'll go ahead and put that up here now. Here we go. Sine of 285 degrees times the sine of 75 degrees. And we want to go ahead and use our product to sum identity. So the one we're going to have to use is sine A times sine B. So if we look for that, what is sine A times sine B? That is 1/2 cos A minus B minus cos A plus B. So if we're going to do this, wherever we see A, whoops, sorry, you can't see that. Whenever you see A, we're going to go ahead and substitute with 285 degrees. And whenever you see B, we're going to substitute that with 75 degrees. So we've identified our proper form. We've identified our variables. So now it's time to go ahead and simplify this. So we will say sine 285 degrees times sine of 75 degrees is 1/2 cos A minus B cos 285 minus 75. Cos 285 degrees minus 75 degrees minus cos A plus B 285 plus 75. And let's see what that's going to give us. Sine 285 times sine 75 degrees is 1/2. 285 minus 75, I believe, is 210. So we get 1/2 cosine of 210 degrees minus cos 360 degrees. Well, I've got to do both of these. I've got to find cos 210 and I've got to find cos 360. So how can I do that? Well, let's visualize where 210 is. That's 80 plus 30. So I am in quadrant number 3. In quadrant number 3, cosine is negative. So cosine 200 degrees is negative cosine, and the reference angle there is 30 degrees. Cosine of 30 is the same as sine of 60. Remember, we did our little chart before. Cosine of 30 is what? Is root 3 over 2. Sine of 60 is root 3 over 2. So here we get minus root 3 over 2. So I have 1/2 cos of 210 is minus root 3 over 2. Minus cos of 360, well, what's that going to be? 360 is the same as 0. So here is 360 degrees. And the point there, of course, x is 1, y is 0. So the cosine of 360 is cos of 0 is 1. Cosine of 360 degrees is 1. So minus 1. Now I will distribute because I have multiplication over subtraction. So let's go ahead and do that. This times this minus this times that. What do we get? 1/2 times negative root 3 over 2 is negative root 3 over 4 minus 1/2 times 1 minus 1/2 as my final answer. Okay, well, what are we going to do here? We're going to go ahead and do some other problems, rewriting these things, products to sums and sums to products. What we've done so far have all been dealing with numbers. We're going to go ahead and do some more algebra this time and looking where we're going to get. So let's see, keep my identity sheets handy. And what I'd like to do next is I'd like to take a look at cosine of 4x, cosine of 2x. So what will that be? Cosine of 4x, cosine of 2x. That is a product, and I want to rewrite that as a sum or difference containing only sines or cosines. Can I do that? Well, I have an identity. I need cos times cos. So if you look at our product to sum identities, cos times cos, 1/2 cos A minus B plus cos A plus B. So I'm going to write that down underneath this, make the substitutions I need, and then go ahead and simplify it. So I've got my cos A, cos B identity working for me there. Let's write that down. Cos A, cos B. Cos A, cos B is 1/2 cos A minus B plus cos A plus B. And I have to be honest, I don't have these memorized. So if I make any errors, if I miscopy something, please tell me in the comments so I can fix it. but I'm trying to check as I go, so I believe that's correct. So now what do we have here? We have A is 4x, and we have B is 2x. So wherever I see an A, I'm going to write 4x. Wherever I see a B, I'm going to write 2x. So I have cos of A, cos 4x, cos of B, cos of 2x. Is 1/2 cos of A minus B, cosine of 4x minus 2x, plus cos of A plus B, cosine 4x plus 2x. So what we get here is we get cos of 4x. Cos of 2x is 1/2. 4x minus 2x, that's cos 2x. Plus cos 4x plus 2x, that is cosine 6x. So we're able to rewrite that in a fairly nice form to go ahead and get 1/2 cos 2x plus 1/2 cos 6x. If you want to distribute the 1/2, I guess you could. You could say 1/2 cos 2x plus 1/2 cos 6x, but I'm not really sure that was necessary. The next example is a little bit more challenging. We're going to take a look at sine of 3x over 2, cosine of x over 2. Just want to remind you we have homework due on Tuesday. So make sure you get that finished and upload it before midnight before 11:59 on Tuesday evening. I'm going to strongly encourage you to come to class during your class time. I will be in SEO 430 in the old Math Learning Center. That building is not being picketed. So if you want to come to stop by SEO 430 during my usual class times, I will be to help out on the homework. The learning assistants should be there too. Okay, so this time I have sine A times cos B. Let's take a look at our sheet to see which identity we need. Sine A times cos B. Sine A times cos B is right there, 1/2 sine A plus B plus sine A minus B. So I'm going to write that down underneath my problem. So writing the identity down, sine A cos B equals 1/2 sine of A plus B plus sine of A minus B. And you know my usual strategy, let's define A and let's define B. So A is defined here as 3x over 2, B is defined as x over 2. So let's go ahead and make that substitution. Sine A, sine of 3x over 2, cos B, cos x over 2 is 1/2 sine A plus B, that's 3x over 2, plus x over 2. A is 3x over 2, B is x over 2, plus sine A minus B. A again is 3x over 2 minus B is x over 2. That's A, ba-boom, that's B, ba-boom. Okay, continuing, what do we get? We get that this equals 1/2 sine 3x over 2 plus 1x over 2 is 4x over 2. 4x over 2 is the same as 2x. Plus 3x over 2 minus 1x over 2 is 2x over 2, which is just the same as x. And if I wanted to distribute the 1/2, I certainly could do that to make it 1/2 sine 2x plus 1/2 sine x. So we've been primarily focusing then on the product to sum identities in our last couple problems. The next ones we're going to do are going to look at sum to product. So we're going to start with the sum, and we're going to go ahead and rewrite as a product. So let me go ahead and remind you of those identities, and then I'll give you a problem to do. So here are our sum to product identities. The one I would like you to do is cos x plus cos 3x. So cos x plus cos 3x. I'll give you a hint. The identity we need to use is cos A plus cos B. This is the one you have to do. So you want to write that underneath. A is going to be x, B is going to be 3x. So let me give you a chance to work on that one. See if you can do it, and go ahead and put your answer in the comments once you get there. So see what you can do. So again, homework to Tuesday before 11:59. Please consider coming to SEO 4:30 tomorrow during the usual class time to complete the homework. The My Math Lab deadlines are still in place. Our exam is scheduled for 2 weeks from Monday. So 2 weeks from tomorrow. So that's coming around. And this is certainly the most challenging of the homeworks of the exams. So see what you can do there. All right. Can we get someone to post an answer on the comments? All right, we have an answer, 2 cos x over 2 cos negative x. Not quite, I don't think, but pretty close. Pretty close. 2 cos 2x cos negative x. Again, pretty close. We can actually simplify that a little bit, though. Do you remember what cosine of negative x was? That's one of our rules that we looked at a week or two ago. But yeah, nice job. So we have our situation here. A is x and B is 3x. So this will be 2 times cosine. A is x plus B is 3x over 2 cosine of x minus 3x over 2. So what does this become? Cosine of x plus cosine of 3x is 2 cos. 1x plus 3x is 4x. 2 cos 4x over 2. 1x minus 3x is negative 2x over 2. And then we can continue this to the end, and we get cos x plus cos 3x is 2 cosine. 4x divided by 2 is 2x. Negative 2x divided by 2 is cosine of negative x. So yeah, we had that answer on the board and one close to that, so good work. All I want to remind you is cosine is an even function. So recall a couple important facts. Sine is odd. Sine of negative x is negative sine x. However, cosine of negative x is cosine x. We showed why looking at the graphs. The graph of cosine looks like this. So there's cos x, there's cos negative x. You can see they're at the same value. So cosine of negative x is the same as cosine x, so that my final answer here would be 2 cosine 2x cos x. That's rewriting this from a sum to a product. Now, you could certainly rewrite it several other ways because you have 3 different identities for cosine 2x, but we'll go ahead and leave it like that as our final answer. All right, there's one more that I want to work on in the world of sum to product. Let's take a look at the following. We're going to look at sine of 4x minus sine of 2x. So we have sine of 4x minus sine of 2x. We need to find the proper identity for us to work with to do that. And it looks like I found it here. Sine of A minus sine of B. Let's get it so it's flat. So you can see in that case, A is 4x and B is 2x. So if I make my substitutions, then what do I get? I get 2 sine A minus B, 4x minus 2x, over 2 cosine A plus B, 4x plus 2x, over 2. What does this become? 2 sine 4x minus 2x is 2x over 2. 4x plus 2x is 6x over 2. And I wind up with 2 sine x cosine of 3x. So those last two examples were sum to product. The previous two examples were product to sum. And now we're going to go ahead and actually prove some identities. So we're going to finish up today's lecture by trying to prove some challenging identities. So let's see if we can do that. We'll keep our sum to product and product to sum identities close at hand because we will be using them as we go along. So here's the first thing that I would like to prove. I get this centered pretty well. So here we go. The thing I want to prove is sine of theta plus sine of 3 theta prove sine of theta plus sine of 3 theta over 2 sine 2 theta equals cosine theta. That's what we want to prove. So we're going to use our various identities to get there. Start with the more complicated side. The proof we did earlier in tonight's lecture started on the right-hand side, although most of the time the left-hand side is more complicated, and that's certainly the case here. So I've got left-hand side is sine of theta plus sine of 3 theta over 2 sine 2 theta. There's a lot of things we can do here, but today's lesson is on product to sum, sum to product. That's a sum. Can I rewrite that as a product? Well, if I have sum to product, that's sine plus sine. Let's make a quick note of that rule. So over here on the scratch paper, I'm going to look at sine plus sine, sine A plus sine B. Sine A plus sine B is 2 sine A plus B over 2. 2. Sine A plus B over 2 cosine A minus B over 2. And you can see in my problem I need sine theta plus sine 3 theta. So according to that, A is theta and B is 3 theta. What will that give me? Equals 2 sine A plus B over 2 theta plus 3 theta over 2. Cosine A minus B over 2 theta minus 3 theta. Okay, let's keep going. What do we get here? This is 2 sine theta plus 3 theta is 4 theta. Theta minus 3 theta is negative 2 theta over 2. 4 theta divided by 2 is 2 theta. Negative 2 theta divided by 2 is negative theta, but recall what we said on the earlier page. Cosine is an even function. If cosine is an even function, cosine of negative theta is the same as cosine theta. So what I get this equals is 2 sine 2 theta cos theta. So we've done all that work, and that is the top of this function up here. So we have left-hand side equals this. Sine of theta plus sine of 3 theta is 2 sine 2 theta cos theta. But again, this should be on scratch paper away from your work. And downstairs we have 2 sine 2 theta. At this point, you can recognize we have a lot of nice cancellation, don't we? The 2 goes away by 2. The sine 2 theta goes away. So I have cos theta over 1, which of course equals cos theta, which is the right-hand side, which makes me happy that I have left-hand side equals, 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 equals right-hand side. Therefore, the proof is completed. So that one wasn't so bad. The hardest part, of course, was using this sum to product identity to go ahead and simplify that. Okay, let's do another one in that vein, if I can. So this one will be challenging as well. Don't forget, sine is odd, cosine is even, tangent is odd. Those will be important facts for us to use. So here's the next problem I want us to prove. This will be challenging. Take a look. Prove cos x minus cos 5x over sine x plus sine 5x equals the tangent of 2x. That's what we're going to try to prove, and we'll see if we can do it. So I need cos minus cos, and I need sine plus sine. So as always, let me start the problem. I like to underline what I'm trying to prove. And then we'll say left-hand side equals cos x minus cos 5x over sine x plus sine 5x. Then I'm going to get my scratch paper handy. Let's may take some work here to get this done. But I'm going to start with cos a minus b on one side. So cosine a minus cosine b, that's what I wanted to use. Cos a minus cos b is negative 2 sine a plus b over 2 sine a minus b over 2. So this time I have cos x minus cos 5x. A is x minus cos 5x. B is 5x. So I get negative 2 sine x plus 5x over 2 sine x minus 5x over 2, which gives me negative 2 sine x plus 5x, that's 6x over 2, 1x minus 5x, negative 4x over 2. So I get negative 2 sine 3x sine negative 2x. And remember, sine is an odd function. Sine of negative x is negative sine x. So in this case, sine of negative 2x is negative sine 2x. So what I get here is I get negative 2 sine 3x times negative sine 2x. Well, negative 2 times negative is positive 2. So I get positive 2. Then I have sine 3x times sine 2x. Hope that's right. So that's on the top. That's cos x minus cos 5x. So we'll put that up top, which is 2 sine 3x times the sine of 2x. Now we've got to also do the bottom. So that's sine x plus sine 5x. So I need sine A plus sine B to make that work. So I'll give you a minute to get this copied down. And then we'll see what we get there. So we'll go ahead and put those values. Also, I have posted the discussion sheets for the week. If you go on the Blackboard page, you can see the discussion sheet week 11 for Tuesday, week 11 for Thursday. I do not think there will be any discussion sections this week, so I encourage you to work with your classmates to complete those discussion sheets on your own. And it's a good way to test yourself that you're staying on top of the concepts in this most challenging part of the course. All right, so I'm going to need to write down my sine A plus sine B stuff. So sine A plus sine B is 2 sine A plus B over 2 times cosine A minus B over 2. And we need sine x plus sine 5x. So, of course, A will be x and B will be 5x. What's that going to give us? to sine x plus 5x over 2 cosine a minus b x minus 5x over 2. And what is that going to give us? 1x plus 5x sine 6x over 2 cosine x minus 5x negative 4x over 2. Then what does this become? This becomes 2. 6x over 2 is 3x. Negative 4x over 2 is negative 2x. But again, remember, cosine is even. Cosine of negative x is cosine x. So cosine of negative 2x equals cosine of 2x. So the final part of the denominator of this proof is going to give me 2 sine 3x cosine of 2x. That, of course, is sine x plus sine 5x. So go ahead and make that substitution up here. So we get 2 sine 3x cos 2x. Now take a look at what we're trying to prove. We want to prove that the left-hand side equals the tangent of 2x. Are we there yet? So here is our problem we wanted to do. So we've done all that substitution work. We've gotten this far. So I hope you can see that the 2's cancel. 2 divided by 2 becomes 1 over 1. Sine of 3x over 3x divides out, becomes 1 over 1. So I wind up with sine of 2x over cos of 2x. So we can put this away now, I think. So this equals 1 times 1 times sine of 2x over 1 times 1 times cos of 2x. Sine of 2x over cos of 2x, of course, is the tangent of 2x. And the tangent of 2x is what? Is the right-hand side. So that makes us happy. There's one more on the sheet that I won't have time to do before we hit the 50-minute mark, but I will ask you to try this on your own. So I'd like you guys to try sine A plus sine B. So after I stop here in a couple minutes, see if you can prove this one. Sine A plus sine B over cos A plus cos B equals tangent of A plus B over 2. So I'll let you try that on your own. And yeah, just like, again, a couple of reminders. So during the duration of the strike, I plan to continue doing these lessons more often than not in the evenings when I think more people can participate. So hopefully you can continue joining me live if your schedule permits. If you can't join me live, I will, of course, make them available to watch later. As I said, homework due on Tuesday evening. So I'd like you to work on that Monday. In your the usual class time, go to the Help Center in SEO 430. That will not be picketed, so you're not crossing the picket line going there. Keep in mind, of course, that your My Math Lab schedule stays in place, as well as the exam. Again, the exam is 2 weeks from Monday, so that's coming fairly quickly. All right, my friends, I will be on campus tomorrow, so stop in and say hi. If you have any questions, of course, I will take them via email as well. Thank you for coming to the live portion of this, and I wish you the best as we continue through this difficult semester. Ciao.